All right, we will go ahead and get started. Welcome, everybody, to the first webinar in the HFES Aerospace Technical Group webinar series. My name is Rodrigo. I am a system safety engineer working for Beta Technologies, an eVTOL company. And at the same time, I'm also a volunteer with the HFES Aerospace Technical Group. And I'll be hosting this series of webinars over the next few months to highlight some interesting and fun projects that are going on in industry involving human factors in aerospace. We're really excited to have here for our first webinar, Cameron, Patrick, and James from the Agility Prime Initiative. They're going to be talking about a recent project that they've been working on. And the way this webinar is going to work is we'll have them talk for the first 20 to 30 minutes of the webinar. Then I will ask a few questions, and then we'll open it up to the audience to ask all of your questions. So we'll try to keep everybody muted and cameras off throughout the presentation. And then when we get to the Q&A portion, you can raise your hands in Zoom and we'll call on you to ask your question. One quick reminder to everybody, this meeting is being recorded and it's going to be posted later on. So if you had friends or colleagues who weren't able to attend right now, they can watch this meeting later on. We'll post an announcement in the ASTG forum about where and when this is going to get posted. But just keep in mind, the call is being recorded. With that, I don't have any further announcements, so I'll turn it over to the Agility Prime team to introduce themselves, share their screen, and get on with their talk.
Awesome. Thank you so much, Rodrigo. And James and Patrick, I know that I'm putting you a little bit on the spot here, but if we want to each go through introductions, just so people know who they're talking to, I'll start off. Lieutenant Cameron Kesters just joined the Air Force about a year ago, and I've been working on the eVTOL project here at Edwards Air Force Base since then. It's been an amazing opportunity, and I look forward to telling you all about it in just a moment.
Yeah, hi everyone. I'm Patrick. I've been working here at Edwards Air Force Base as a human factors engineer for a little over a year now. And much of that time, my work has been on the project that you're about to hear about. So yeah, over to James.
My name is James Cunningham. I've been a human systems integration engineer at Edwards Air Force Base now for almost 10 years. I've been working at the Emerging Technologies Integrated Task Force for almost 7 years of that, six or 7 years of that, and been involved with various aspects of the Agility Prime effort. The most recent one is what Patrick and Cameron are going to present here today. Somewhat related to, if you guys saw the presentation I gave at the Human Factors Conference this year, they're just going to go into more detail, make it more interesting. There we have it.
Awesome. Thank you so much, both. So we're honored and excited to be here today. Really appreciate you guys coming out and listening to this presentation. So by coincidence, just last week, I gave this presentation at a conference in Arlington, Virginia. And at that conference, we were talking about different visions of the future. And the analogies that we made were through different TV shows that we watched growing up. So the Jetsons came up, and for me personally, that was Star Wars. So in different scenes, you can see people loading and unloading off of aircraft on the sides and tops of buildings and zipping through skyscrapers. And so it's an honor to be a part of making that future vision a reality. And I hope you guys are too. So I'm from the Emerging Technologies Integrated Task Force, as James mentioned. And so I'll be talking a little bit about some of the early successes and focus areas of the eVTOL program. Patrick is our resident HSI person who's been working tirelessly on the human factors portion of this project. As an engineer, it's always been about the vehicle and what do the nuts and bolts do. But it's really been an eye-opening experience to see how much of the human portion is involved, especially in this program. So if you give me one moment, I'll pull up my slides. It's a good thing I'm engineering and not IT. Those are two different fields for a reason. All right, can I just get a quick confirmation that you're seeing slides?
You see the slides? They're not full screen. We see the PowerPoint. But
That's
yes.
weird. Oh, interesting. All right, well, let's try this again. All right, how about now?
There we go. Now we see them full screen.
Awesome. Thank you. Sorry about that. So really the focus of this presentation originally was how are we integrating eVTOLs into a military environment, and what are some of the different use cases for these types of aircraft. And what we found is, like I mentioned before, unlike the traditional type of test that we do here at Edwards, where it's about the nuts and the bolts and how high, how fast can it go, this is really about the human experience with this vehicle and how can it better the organizations on base and their different mission sets. You know, the type of thing is, what does this unlock? What are your concerns? And what can you do differently with this aircraft? And how does this change the way that you would approach your different mission sets? There we go. So there are really four overarching topics that this program aims to support and improve where we can. This is not an all-inclusive list, but these are just the high-level overarching main topics. So USAF involvement in transformative vertical lift. We'll talk about a little bit who we are as an organization and the eVTOL program that we have here. Vertical lift is a pretty wide market, and just want to make it clear that the test team here focuses on eVTOL specifically. Then we'll talk about how we support our contractors partner test. So here at Edwards, right now that's Joby Aviation, and we'll talk about how we integrated them into our airspace and some of the infrastructure challenges that we were able to overcome. Then we'll talk about executing government tests with industry partners. That's the meat and potatoes of this presentation, talking about the different things that we're considering and looking into with this type of test. And then what have we learned and where do we go from here? So we are the Emerging Technologies Integrated Test Force. And the whole purpose of this organization was to stand up a place where we could investigate different types of technology that may not have otherwise been tested by the government. And what makes us different is we tend to investigate technologies prior to starting the acquisition cycle. So before the Air Force goes into its traditional forever and a day process of finding a need, finding a technology that fills the need, testing, and then producing the technology, we take a look at tests prior to the start of that cycle. So we are not a program of record, or none of our programs are programs of record, kind of like the B-21 or F-22. this is our vision, and the thing that I'd like to highlight here is platform agnostic. So our programs here are focused on a particular platform, and that's by necessity. But what we do is we take the data that we collect and test and then draw high-level conclusions about its utility to the warfighter. And then finally, these are our focus areas. So for small UAS, we participate in a variety of base exercises. We investigate counter UAS techniques and even assist other bases in their own UAS programs. For autonomous aircraft systems, we have a program going on right now where our engineers are creating an aero model of a small UAS, and they're using that model to train an autonomous system. And then finally, government industry collaboration. This is a prime example of that initiative, and I'll go into a little bit more detail later on in the presentation about how it is we approach that. So the spoiler alert is on the slide. We support Agility Prime. If you trace the organization chart all the way back, it goes to the Air Force Research Lab. And within the Air Force Research Lab, it powers AFWERX, which is the innovation arm of the Air Force. AFWERX has a lot of different initiatives, and the one that we support is Prime. Then within Prime, there are different technology focuses, and Agility Prime's focus is on electric and hybrid aircraft. So the whole point of Agility Prime is to invest early funding and feedback into different technologies of hybrid and electric aircraft to be able to provide a better product to the end user. So on the slide, you'll see a bunch of different organizational patches, including the Air Force, Marine Corps, NASA, FAA, Special Operations Command, and even the U.S. Forestry Service. So all but the U.S. Forestry Service are organizations that we support. U.S. Forestry Service is an organization that Agility Prime has looked into for different use cases. They're not ones that we directly support, although it's just an example of the wide breadth that this technology could be used for. They've also done work with all the different branches of the military. They're just not on this slide because they're not ones that we've worked with directly. So let me take a moment to introduce you to the test bed that we have here at Edwards. This is the Joby S4. It has 6 propellers and it's a tilt rotor. So as you see in the picture, that's the configuration it takes off and lands in. And then as it gains airspeed, the propellers will tilt forward and they'll look more like a traditional propeller on a traditional aircraft. It's got 4 seats, not including the pilot, and it's primarily used for personnel transport, although we're also investigating different cargo transports and a combination thereof. So having an aircraft is great, but we need to actually be able to fly this thing. And being the first of its kind at Edwards, we didn't really have a precedent for it. So we decided to go to Eglin and take a look at how they did it, because why reinvent the wheel if you don't have to? What we found is that there was a lack of trust in the technology that forced a lot of precautions during test that we felt would be hindering our timeline and our tests, and we could still safely execute without the additional precautions. So we went to air traffic control and some experts that were researching air traffic control, and we asked what they thought. And the answer was mind-blowingly simple: treat it like a helicopter. Now, the FAA has since made incredible progression on regulations and how to integrate eVTOLs into the airspace, but at the time we didn't have that. So we needed a local solution that would work for test, and that worked. Air traffic control ran simulations and agreed that it would be a viable solution. So now we have the ability to actually fly at Edwards, which is great, but you need a place to put the aircraft. And there were limited spots that already existed at the test site for us to put the aircraft. So the test team got creative and implemented a solution that's typically found in deployed locations, and that's called the Large Area Maintenance Shelter. The Large Area Maintenance Shelter is a large tent-like temporary structure that, in our case, AFWERX owns. It can store 2 aircraft, charging infrastructure, and some personnel. And all that's great, but there were delays getting there, so we had to come up with a creative temporary solution again. So there was precedent for storing an aircraft in a hangar, but there wasn't precedent for charging an electric aircraft in a hangar. So without going through the hassle of having to remove the aircraft from the hangar, charge it, and then put it back, we decided to take a deep dive into the regulations and see what was actually stopping us. So between the deep dive in the regulations and an independent safety analysis, we really came up with 2 things. And the first is there needed to be a certain airflow when charging lithium-ion batteries in a hangar. So with the doors closed, we did not meet requirements, but with the hangar doors open, we were able to get sufficient airflow. And then on top of that, we would drain any oil from the historic aircraft in the hangar to protect those assets. So Joby electrical engineers, ground safety, fire and emergency services, the test team at Emerging Technologies, and other subject matter experts proposed this solution to leadership, and it was approved. So along the journey, we're proud to say that we set the precedent for charging an electric aircraft in a hangar. So that's one aspect of infrastructure. The other is the electrical aspect. And early estimations showed that we didn't have the electrical infrastructure to be able to support the power draw of normal operations. So, in order to mitigate that, we built a mini substation to be able to provide enough power for charging and flying and supporting the other miscellaneous things that would be needed in order to actually operate here at Edwards. And then the second aspect of electrical infrastructure is energy discharge. So that's kind of like putting gas back into the gas pump. Why on planet Earth would you want to do that? Well, the reason is you can prolong the battery life by storing the batteries at a certain percent of charge. So the best way to do that is to discharge back to the grid, which seems like a no-brainer, but you're trying to make a 2-way system where there was previously built for 1-way. So we worked with our local power providers, and we were able to get approval under existing regulations to be able to discharge back to the grid with Joby charging infrastructure. And then finally, connectivity. So it was a contractor requirement to be able to get connection from their ground control station to the aircraft. The easy button solution would have been Wi-Fi pucks, but due to the high latency, that wasn't a viable option. So we ran a wired connection from one of our buildings to the historic hangar that you see in the photograph. Now, all of this seems like a lot of buildup for one contractor, and I would agree with you. But the whole point of all of this buildup and background is to be platform agnostic. So going back to our vision statement, this is supposed to be a hospitable environment for eVTOL testing as opposed to a hospitable environment for Joby as a contractor. So that's our goal. And all of this also benefits future projects, and we could absolutely find utility for this in the future beyond even eVTOLs. So now that we have the ability to fly and the ability to store the aircraft and we have a place for the people, we have to come up with a non-traditional test approach for a significantly shorter timeline than what Edwards is used to. So really it comes in two parallel parts. The first being company or contractor-led developmental tests. That's your standard higher, faster, expanding operating limits type of test. And then Edwards did a risk assessment that was scoped to Air Force Test Center assets, personnel, and non-participating third parties. And that developmental test establishes the test envelope for a government military utility assessment. So on the other side of the test approach, you have the military utility assessment where the government comes up with different use cases with different organizations on and off base, and will figure out how this can best support any capability shortfalls. And then here on the side, you'll see a couple of our main user groups. These are user groups that are approved in our test plan. This is not an all-inclusive list. This is just who's in our approved test plan at the moment. So in addition to the 412th Range Squadron and 412th Security Forces Squadron, we're also looking into potential medical use cases and fire and emergency services. It's just a start. We're planning on potentially expanding beyond that, but for now, those are our primary on-base user groups. And then in addition to this, what I failed to put on the slide is we're working closely with the Air Force Operational Test Center, or AVOTEC, their experimentation directorate. And they assisted us in writing a test plan for an off-base special forces squadron called the 24th Rapid Deployment Squadron. They specialize in logistics. And for a base that's focused mostly on developmental tests, your higher, faster operating limits, nuts and bolts, it was important to get the additional expertise to get that wider perspective on how do we best do this more operational type tests and aircraft utility and more people focused type test as opposed to what we're used to. So here's the meat and potatoes of this whole test effort. I've broken it up into really 4 categories, but once again, broad brushstrokes. We're looking into a lot of details within these and things that are even beyond the scope of what's on this slide, like mobile charging. But just to start going into it, we have your standard people and equipment mover, kind of similar to what the aircraft contractor goals are. And then in addition to that, looking into how it can be used to inspect different assets around base. So for example, on the test ranges, there are telemetry towers and targets and things like that that the range personnel have to periodically inspect. Well, distance is not your friend here at Edwards. We're a very large base, and that can cause time delays and make simple tasks much longer, like the range inspection. So having an electric aircraft could potentially speed up and expedite these inspections. Additionally, security forces with their perimeter suite. Edwards is, I'll say it again, a giant base. And right now, distance along with environmental factors makes this effort a really huge challenge for them. So being able to get from point A to point B and being able to get a wider field of view is critical for them. Then going into flight path evaluation, we've got normal versus contested airspace. So what does the flight profile look like going in and out of an urban environment or even a rural environment versus if this were used in a deployed location, how would that flight profile change? We're not putting all kinds of crazy armor or other hardware that's typically seen in deployed locations. We're mostly just looking at the flight path evaluation and meeting the technology where it's at. And then another consideration also is battery versus mission efficiency. Doing the best flight profile to maximize battery efficiency is not necessarily the most efficient for mission efficiency. So, for example, if different users want to hover at different points during the profile, hovering takes up a huge amount of battery charge, and it's inefficient for the flight, but it's efficient for the mission. So, how do we find a happy medium and merge the two to find something that works that may not be one-to-one representative of what's currently being done? And then finally, maintenance and reliability. So, mean time between maintenance, there's standard maintenance that's critical for safety, and this is not intended to try and cut that out. What we mean by this is additional maintenance on top of what's required. So, something breaks, how long is it going to be on the ground, that type of thing. And then meantime between failure, ideally you don't have a problem in the air. So that's something that we also want to track. Patrick, do you have any additions on use cases and things that we're investigating?
You covered most of the use cases. I did want to clarify for anyone who's unfamiliar. We've talking a lot about military utility. What that largely means to us here, the official definition is how well a system in question responds to a military need, usually in the context of performing a mission. But so I find it a little easier just to think about it as the usability of the system for a specific mission or mission set.
Thanks for the clarification, Patrick. So once again, not an all-inclusive list, but these are the main overarching topics that we are looking into for the various user groups. And then finally, benefits of eVTOLs. Some of you may think these look familiar. We derived these from interviews with different user groups. We didn't make this up for a pretty slide, but like we talked about earlier, improved response, distance is not a friend here. And it's not limited to just Edwards. There are rural communities which are personal, especially for me, coming from Eastern North Carolina, where hospitals could be uh, too far to reasonably drive, or if you have an emergency, what does that look like? We even had a fatal incident at a nearby test facility, not here at Edwards, but nearby, where it took nearly an hour from 911 call to the helicopter transporting the engineer back to a emergency hospital. Could that person have survived if it didn't take so long between the communication structure and sheer distance from hospital to test facility to be able to save her life? And there have been other instances, even at Edwards, where distance and communication structure have hindered life-saving care. This is not going to replace a traditional ambulance or anything like that. However, can these aircraft get to the scene of an accident or a medical emergency to be able to provide the initial life-saving resources that give someone just enough time for the ambulance and the trained personnel to show up? Next is overcoming terrain. So, contrary to what at least I thought, coming out to the middle of the desert, flooding can be a huge problem out here. And natural disasters like what happened in Western North Carolina are incredibly prevalent. If roads are unserviceable or whole areas are flooded, this type of aircraft can completely bypass that problem of risking driving a truck or some other vehicle through unsafe conditions. And then finally, lower costs. So, yes, we can do all of this with a helicopter. There's no question about that. The problem is helicopters can cost between $1,000 and $2,000 per flight hour. So it makes it inaccessible to a large variety of users. So by reducing the cost to uh, estimates like an Uber Black price point, or even eventually, hopefully, anywhere around $1 a mile, we can make this type of technology is accessible to the people who need it and can use it. So, in conclusion, I just want to wrap up by saying this, despite Agility Prime taking a look at this from a government or DoD standpoint, this goes far beyond an Air Force initiative, a Marine Corps initiative, or any other branch initiative, or the DoD initiative. This has the potential to change how we view transportation across the board and even in urban environments. And it's incredibly important to consider the human in the test and all of these different initiatives because those are our users. And it's not just going to be a military person, it's going to be our families, it's going to be our friends. And we want to make sure that supporting the Agility Prime initiative, we're able to give the best feedback to uh, different companies so they can reach the users. With that, are there any questions?
Great. Thank you so much, Cameron. This was a very interesting presentation. I have a question to get us started. So as I mentioned at the start, I also come from the eVTOL industry, and to me, it's really interesting to think about the challenges that come up in the eVTOL industry when we're talking about human interaction in flight test and in normal operations compared to the traditional challenges that you would see in other segments of aviation that we already have sort of lots of experience with as an engineering community. What do you think are some of those challenges when it comes to human factors that are unique to eVTOL that we might not have that much experience dealing with in other aviation endeavors we've had in the past?
Yeah, great question. So, this is just my opinion, and Patrick and James, feel free to jump in. But the first thing that comes to mind is the level of automation that comes with these aircraft. So, speaking from experience in the general aviation world, you hop in an aircraft of relatively comparable size, and you're the one that has to change the pitch angle of the propellers. You're the one that has to change the mixture control. You have uh, all these different considerations when you're flying an aircraft, even just going from point A to point B. With these type of aircraft, it's so automated that it makes training so much easier and even so much safer because you're taking human error out of the equation. And it's not a perfect solution by any means. I mean, there will always be something. However, by supplementing the human with so much automation and software, you make it safer for environments like a dense urban city for these aircraft to be able to fly. And then there's also the passenger aspect where I'm sure we're all familiar with the slowly decreasing amount of space we have on passenger flights in the commercial Delta, United, pick your favorite airline. Well, with such a small cabin and such a small and intimate group flying from point A to point B, having the collective experience be positive is so important because of uh, the small group that you're transporting, as opposed to, all right, everybody pile on, let's get from New York to LA. So those are just my initial thoughts. Feel free to hop in, Patrick and James, if you have anything different.
Yeah, I also wanted to highlight the kind of tagging on to the whole automation thing. The piloting requirements, right? The FAA is, working on this sort of thing, but like, what is actually required of a pilot in an eVTOL that is highly automated? Do they need nearly as much training as your traditional pilot? And those are very important aspects, especially as it relates to our work here, because a lot of the groups we are interfacing with and we're talking to are not traditionally flying groups. They don't maintain their own pilots, they don't maintain their own aircraft. And so actually using these aircraft it would be extremely beneficial to them if the requirements to train an eVTOL pilot were significantly lower, because then it might make it feasible for them to train their own pilots as opposed to having to keep uh, add pilots to their payroll and significantly expand their expenditures because of that. Whereas if they could just train 10% of their existing staff, that would make it much more accessible and much more useful. A big part of like Cameron was saying with emergency response, a big part of the problem there is that flying units are not necessarily integrated. So it's going through a bunch of different channels of communication to get word to the actual unit that can get a helicopter out or whatever. So cutting down that chain could drastically reduce emergency response times.
Very interesting responses. I have one follow-up question on the same topic of automation that you two brought up. I can definitely see that introducing automation can help eliminate a lot of the human errors that are traditionally associated with flying, but it can also introduce some new complications as well, right? I'm thinking of things like automation mode confusion, where the automation isn't transparent, and then the pilot doesn't have all the awareness that they would need to know about the state of their aircraft. Those kinds of situations, I think, can arise when we have systems that are more automated and less reliant on the pilot being monitoring everything at the same time. Have you encountered those kinds of issues in the testing that you've done? How do you deal with them if they do come up?
We haven't really encountered them, largely because we're kind of focusing on the bigger picture of what can we even do, like what sorts of things can we even do with these aircraft. We haven't quite made it down to that level of fidelity yet, but that is for sure going to be a very important part of the equation. Even like we've seen with self-driving cars, it's very easy for people to get complacent and not really pay attention when things get automated.
Great. Yeah, I agree.
Real quick to add on to that, so the FAA has actually been doing great work in working on that problem. So there will be or at least the current plan that I've heard is to create a type certification for the different aircraft. So just because you're cleared on Joby doesn't mean you're cleared on Beta. For that very reason, they're so vastly different despite both being eVTOLs. And it would be incredibly it would be incredibly dangerous for a pilot to assume that just because they know how to fly one aircraft, they know how to fly another. And that even exists in the current structure where pilots are encouraged to fly with instructors and get comfortable in a Cessna if they are used to flying in a diamond. So they're able to safely operate the aircraft with the different controls, the different feel to it, different levels of automation, even autopilots, and things like that.
Awesome. I have one more question before we get into the questions from the audience. If we have members of our audience or people who are watching this later on who are looking to get involved in projects of this sort, what kind of recommendations would you have for them on where to look, how to get involved in this industry or in this field of study?
Absolutely. So, one way is to go straight to the source and reach out to eVTOL contractors. That's certainly one way. Another way is if you're interested in the Agility Prime initiative and getting involved from that aspect. If you go to the AFWorks website, there is a fellowship program that you can apply to, and it shows the dates and the application process on the website. So I highly encourage you to take a look at that and take a look at some of the different opportunities that they have there.
Awesome. Okay, we have one question from our audience, or actually a few now that have come in. First one is, was a rated pilot flying during your tests?
So right now, Joby pilots are flying the aircraft, and for government directed, the military utility assessment, there's really two types of tests that we'll be doing. One is we'll develop test cards and different test points and hand them over to the contractor to execute themselves. So they'll be using contractor pilots. And then later down the road, we'll be using trained government pilots on the system. So um, all trained appropriately on the aircraft. It's just a matter of the level of progression.
Okay, our next question is, was aircraft operation strictly at the vast flat desert landing area at Edwards, or did you go into coastline, mountains, forested, confined landing areas?
So at the moment, we're mostly in the envelope expansion part of test. So the contractor's working on getting the envelope to a point where the government is able to jump in and do um, meaningful test. So we developed a minimum viable envelope, and we are just now getting to the point where soon we'll be able to execute government directed tests. So I just want to be clear that we don't have the data yet, but the approach that I talked about earlier is our plan to jumping in and doing that parallel approach. So going back now to answer the question, um, testing at Edwards is mostly over a whole lot of vast nothing desert. However, Joby has done testing up at Marina, which is more of a maritime coastline environment.
Right, and the third question we have in here is, was any STPA used for risk and hazard analysis? For those of you not familiar, STPA stands for System Theoretic Process Analysis, and it's a hazard analysis tool that incorporates humans and software and all that into the analysis. Was any of that used for the hazard analysis?
So, the Edwards Range Safety Team has their own software that they use for all the different programs here on base, and it factors in altitude, speed, flight profile, locations, and things like that to develop really two things. One is a probability of impact map where it'll show based on the flight profile where if something were to happen and you have a catastrophic event in the air, where is the aircraft likely to impact on the ground? And then the second is based on those locations, a casualty estimate. And the casualty estimate factors into our negligible, low, medium, high, and unacceptable levels of risk when we're doing a safety analysis. So if that references, I'm not familiar with it, but if that references a particular software, then that's not what we use on base. However, we do use something similar to factor in all those safety concerns.
Okay, interesting. Yeah, STPA isn't a software, more of just a methodology for doing hazard analysis, but it's interesting to hear the kinds of hazard analyses that go on for these tests. I always find it kind of tricky to uh, be able to do a holistic assessment of risk when you have things like human error involved or erroneous software behavior where it's difficult to quantify. So it's interesting to hear how that's done using different tools. Do we have any
Yeah, and
more
that's just
questions? Yeah. Go ahead. Sorry.
oh, no worries. I was just going to say that the holistic approach that you mentioned, this software is not the end all be all. It's just one facet of the safety review that's done for all the tests at Edwards. It is one part of a safety review that's done by a board of different technical experts, including uh, flight sciences. Sorry, it took a second to get there. And the range and a safety chair where the test team will develop a plan of test unique hazards. So all of the things that you were just mentioning go into that plan. And then that software is in addition to all of those considerations. So you get both a quantitative and qualitative analysis to get that holistic approach.
Nice. Very interesting. Thank you for that added insight. Do we have any more questions from the audience? You can also feel free to raise your hand on Zoom or just unmute and ask questions if you don't feel like putting them in the chat. I'll ask another question of my own if we don't have any other ones. What aspects of the project did you think were particularly challenging or you would have done differently had you had the chance, had you had all the knowledge that you have right now to kind of avoid those challenges in the past?
Yeah, that's a great question. I don't think it's so much the test approach or even the infrastructure aspect or even things that we're considering. Um, a lot of it is hindsight. And so, knowing what we know now, we could absolutely expedite all that process and jump straight to the solution. But I don't think there's one thing in particular that I can think of. My personal opinion is that the process and the failures along the way were critical to getting where we are now. And could we have done things differently? Sure. But all of the little pieces add up to the overarching successes. Like, if we hadn't really failed our timeline in getting the large area maintenance shelter up, we wouldn't have had the opportunity to figure out how to set the precedent for charging an electric hangar. Could we have gone back and changed things in how we approach the timeline to get the lambs up? I'm sure. But we've been able to accomplish a lot because of the little failures and direction changes along the way. And Patrick and James, feel free to add in. I know James has been contributing in the chat. His mic was having an issue, but I'll turn it over to them.
Yeah, there were a couple things I can think of. Number one, it was kind of challenging figuring out how to run our testing in conjunction with the envelope expansion process of the aircraft. We have the aircraft here now. We didn't want to waste time waiting for the entire envelope to be cleared when we could be getting good data during downtime and envelope expansion. But at the same time, there's a lot of portions of the use cases that we can't reasonably do until certain portions of the envelope is cleared. So it took us a while to settle on a strategy for taking advantage of that. But ultimately, we settled on defining certain partial envelopes in which we can do certain portions of the testing. For example, some of our missions require low and slow flight, something that's pretty easy to do with this restricted envelope. And so we kind of broke stuff out that way and figured out how to test it without having an entire envelope. One of the other challenges, I mentioned many of the units we've engaged with aren't traditionally flying units, which means that they don't have checklists or procedures or even necessarily an idea of what they're interested in doing with the aircraft. They're looking at, to improve their operations, what they're currently doing with ground vehicles or whatever, and improving that with an aircraft. But it's not necessarily a one-to-one, right? You can't just go, oh, you're doing this with a truck. Okay, we're going to replace it with an aircraft now. For a number of reasons that usually just doesn't work. So it's really, we've had to sit down with them and kind of talk things out and really figure out what the point of what they're doing is and how the aircraft can benefit that without just replacing a truck with it.
Does anybody have any more questions in our audience? If we don't have any more questions, I think we can end it here. Cameron, Patrick, or James, do you have any closing statements you'd like to make, or are we good to call it a day?
I would just put out, if anybody wants to talk to us, feel free to reach out to any of us. You could probably get my contact through Rodrigo, probably Cameron and Patrick as well. Feel free. We'd love to talk.
Yeah, absolutely. If you'd like to get in touch with Cameron, Patrick, or James, just reach out to me and we'll get you in touch. All right. Well, thanks everyone.
Thanks for having